All right, so on 7.6, there's a worksheet. It's called specific heat. We need to talk about specific heat. Specific heat is a concept by which if I'm going to put something on a fire, a pot on a fire, put something in it, I want to heat it up. The question is, how much heat do you have to put in to make the water change its temperature? Turns out the short answer, after much discussion in class, is H equals mc T minus T naught. All right, so what's these pieces mean? So this is heat. It's being measured in an old friend called joules. And joules of energy it takes to heat something up, that's our energy measurement from back when we talked about light, how much energy light has. This is our old friend mass, which is our weight. It's measured in grams. Okay, and this is our final temperature. Sorry, that's completely wrong. That's not our final temperature. That's our initial temperature. In other words, our temperature at the very beginning. Initial. So before I apply any heat, what's the temperature where it starts? Because it starts at 10 degrees, you want to get to 100 degrees. It takes less energy than if you start at 5 degrees, right? You already got 5 degrees taken care of. Okay, then over here, I have the final temperature. And here I have this C right here is something brand new. These are parentheses here, by the way. That's a parentheses, that's a parentheses. Right, that's a parentheses there. Okay, the specific heat is something different. Specific heat is the how much heat it takes to make 1 gram of a material change 1 degree. I'm going to say Kelvin, but Kelvin and Celsius, same thing. Also Celsius. Okay? So, if we go back here to specific heat, that's my definition. It's the heat necessary to change 1 gram, 1 degree Celsius. Okay? Now, again, you can use degrees Celsius, you can use degree Kelvin. Both of those are equally fine. There's not a problem there because they give you the same number either way. All right? So, again, specific heat capacity, that's C, or we can just call it specific heat because we don't want to say all those words every time. By the way, it's measured in some really unusual units. It's measured in joules per gram degree Kelvin. Okay. All right, so now we're going to get started on this problem right here. It says 6,500 joules of heat are absorbed by 101 grams of aluminum at 15 degrees Celsius. What's its final temperature? So I'd start off with, okay, H equals mc T minus T naught. In other words, the heat necessary to do this is going to change my mass from this temperature to this temperature right here. So now I just plug in some numbers. This is 6,500 is equal to mass. That says 101 grams. Okay. And then specific heat capacity. So that's how much it takes to heat up aluminum. Now, most people don't know that number. But fortunately, I'm going to provide you that number every time because I don't want you to memorize it. That would be a waste of time. So this table right here is where you can find all the numbers. Specifically, here's aluminum. And the specific heat for it is 0.903. So that goes right here, 0.903. Okay. And then what's the final temperature I want to go to? Don't know. It says, what is the final temperature? Put a T here. And then what's my initial temperature? That's my starting temperature, which is 15 degrees Celsius. Put a 15 right here. The rest is just algebra. Okay, you can find this is the final temperature. That's what I'm asked to do. So there's that. Now I'm going to go ahead and do the algebra for you because some people had trouble with algebra in class. So here we go. 6,500 equals 101 times 0.903. So multiplying those first two things together, combining like terms as it were, we get 91.203. And then my final temperature I don't know. Initial temperature is 15. Okay. All right, so most people in class want to use the distributive property to simplify this, so we'll go ahead and do that. 6,500 equals 91.203 times T minus 91.203 times 15. And that gives me 1,368.045. All right. How do I solve from here? I'm going to add this to the other side, and I get, where's my pen? Here's my pen. My pen right there. Okay, so it's going to be 7868.045 equals 91.203 T. Okay, and then I divide that across, right, because that's what we do in algebra class. And I get the final temperature of the aluminum is 86.269585 ... Okay, so over here, this is only good to 2 digits, so I have 6 degrees Celsius, and I am done. And so again, all I did is I said the heat necessary to change the temperature of something is equal to its mass times the specific heat times its final temperature minus its initial temperature. Okay, we do the same thing for this one right here. What is the mass of copper if 1,500 joules of heat raises the temperature from 25 degrees to 75 degrees? Okay, the answer is right down there. It might not be the right answer, so let's go ahead and do it. So the heat necessary to do that is going to be H equals mc T minus T naught. If I start with 1,500 joules, it says, what is the mass? That's what I don't know. Specific heat of copper, again, got to give that to you, and it's right here on the table, right this spot right here. So I got 0.385. Final temperature is going to be 75. Initial temperature is 25. Doing as your math teacher taught you, you get 1,500 equals m 0.385 times 50. And 1,500 equals 19.25 m's. And then I got to divide that across. And I get 1,500 divided by 19.25. And I get the mass would be 77.922077792. Sorry. Okay. This is only good at 2 digits. So therefore, this is only good at 2 digits. So I'd say 73 grams. We're talking about mass. Okay. And that's how these problems are done for this worksheet. Okay. I'm going to do one more with you in just a second. All right. Here's the next problem. I have a 25 gram copper calorimeter, and I'm going to put water in it. Copper calorimeter is basically a cup. And so it's 25 grams of copper. So I'm going to go up here. Hold on, I got my pin back here. Oh, there it is. So I'm going to pour, I got some copper, and I got its water in it. I'm going to take a chunk of something else, substance X. I'm going to throw it in the water. And its final temperature when it's all done is 45 degrees. What's the specific heat of substance X? All right. So here we go. So starting out, I would go, okay, well, I've got H equals, I've got the water's going to change temperatures. Also, the copper, this little container, it's going to change temperatures. Plus, substance X is going to change temperature, right? You throw it in the water, it's going to get colder. Whoops, I did that wrong. I should just, you know what? Let me clean this up. Let me put just a hot minute, making this better. Okay. So, what's going to happen here is the copper is going to change temperature plus substance X is going to change temperature plus water is going to change temperature, right? All those are going to change temperatures. So, is there any heat from the outside world? Now, it's not sitting on a boiling pot, it's not on a hot plate or anything. So it turns out the only thing providing heat is going to be substance X. And so I go put a 0 here. The changing temperature formula for everything is mc T minus T naught. That's true for copper. It's true for substance X. And it's true for the water. Right? So right here we have, so the first thing it says is the copper calorimeter. So the mass of the copper calorimeter is 25 grams. Its specific heat is 0.385, which is really easy to heat up. Final temperature is 45. Initial temperature for that was 30. How do I know it's 30? Well, the water inside it was 30. It's been sitting there for a long time. The cup has to be the same temperature. What's the mass of substance X? It's 50. What's the specific heat of substance X? Well, it says right here. That's what I want to find out. I can't find that out yet. Final temperature is 45. Initial temperature was, substance X was initially at 100 degrees. Put 100 here. Plus, I got my water change temperature. So my water was 90 grams. 90 grams. And then my specific heat, using specific heat formula right here, is 4.180. How do I know that? Again, it's got to be on my chart for water. Right there it is. 4.180. And then my final temperature was 45, and my initial temperature was 30. The rest is just slam it in your calculator equals, right? So I would go 0 equals 25 times 0.385 times 15 plus 50 times C times negative 55 plus 90 times 4.180 times 15. Okay. Multiply the first three things together, and I get 25 times 0.385 times 15, and I get 144.375. And then over here I get 50 times 55, or negative 55. And I get negative 2750 C. And then here I've got 90 times 4.180 times 15. And I get 5,643. Combine like terms. These two are like terms, so I'm going to add. And so I get 0 equals, I get 5787.375 minus 2750C. We'll move this to the other side by subtracting. Try with the bad writing. And I'll go over here. And we got negative 5,787.375 equals negative 2,750C. I divide that. And my specific heat capacity is 2.1. Now I check my units. How's my units and everything? Well, the problem says 25.0, 30.0, 50.0, 45.0, 100. Okay, so it's going to be 2.10. How do I find the units? Written right here. So it's going to be joules per gram degree Kelvin. And that's my specific heat capacity. And that is the answer to that question. The rest of the worksheet you should be able to do, so go ahead and try that out.